Hey everyone, Mike back. What is it? It's Monday night. Got the cat nearby. And talking about contingency tables. These are sort of weird things in R. I always find the commands a little bit strange for tables and maybe boring to do in a complete lecture, but nice to see in a video. So let's go through this and see how to work with tables. No one exactly knows why they're called contingency tables. It's when we have two categorical variables. And essentially, a contingency table is a table of counts with two categorical variables. You have rows and you have columns. So there's a survey that was given to 4826 young people, and it said, what's the chance you feel you're going to be rich by the age 30? So what's the chance you feel you're going to be rich by the age 30? And they were asked to say almost no chance, some chance, but probably not, a 50-50 chance, a good chance, almost certain. A little bit of an ill-defined survey, but here's the survey question. And you have rows and columns. So you see in bold, we have the row totals summing across, the column totals summing down, and the total number in the table is 4826. So how many young adults were surveyed? 4826. What are the variables described? Well, gender, female or male, and then how they felt about getting rich by age 30. Now, if you wanted to, you could actually create this in R. You could create an object in R, which is this table, and we call it a data frame, and we're labeling what the two variables are. We have female equals this, male equals this, and we're giving row names. So there's a little bit of work in R to make it a table that looks nice. But if you do all this, you get a table in R which looks like this. And that's what? 1, 2, 3, 4, 5, a 5x2 table. Now there's a command in R that knows how to work with tables. It's called prop.table for proportions. You give it a table of counts, and it comes back and gives you a table of percentages. You might also call this the joint distribution table because it says, for example, around 12% of people are at the same time male and almost certain they'll be rich by age 30. 13.7% of people are female and feel there's a good chance they'll be rich by age 30. So you have a table. If you added everything up in this table, it'd be 100% because this accounts for every possible combination of gender and how you feel about being rich. Now, the marginal distribution of a table says, let's just look at rows or let's look at columns. So let's look at just one part of the table at once. And so here we have young adults by gender and chance of getting rich. This is the table we start with. And now let's just look at these categories here. 194 out of 4826 feel there's almost no chance. 712 out of 4826 feel there's some chance. 1416 out of 4826 feel there's a 50-50 chance, and so forth. And these are called the row sums. And so this is called the marginal distribution of how you feel about getting rich. If we're adding these values up, we'd see it's 100%. So if it counted for every possibility of the chance of being wealthy by age 30, this is what a graph of that would look like. And this is called the distribution of the rows. You could also do a distribution of the columns. 2367 out of 4826 are female. 2459 out of 4826 are male. But this is called a marginal distribution of the rows. So these are just the row sums, 194, 712, so forth. Divide by the total, and you get this. And again, if we added up these percentages, they would add up to be 1. How do we do this in R? Here's the table we started with. Here's the table of proportions. That's what the prop.table command did. You can add margins here if you want, and all the add margins command does is add down and adds across. So it adds all the rows across, it adds down. If you add these bottom numbers, they add the 1. If you add all these numbers here, they add the 1. And then the prop.table is the overall proportion tables. So again, if you add everything in this table, it would add up to the number 1. I don't know why I went back, sorry about that. Now, doing it by hand, you could create those marginal values by hand. You could give them names if you wanted to, and then you could go plot them. And so if you want to do a bar plot, you would make a nice bar plot, different categories, spaces between the bars, because it's not a histogram, they're categories. And you could make a plot like that. Easier to tell R to do it directly from the data, but if you wanted to do all those steps, you could do it. Now, what we just saw, we call those conditional distributions, and we examine them we can split them up by, say, men and women and see how they differ. And when you do that, you get what's called a side-by-side bar graph or a segmented bar graph, and they're pretty cool looking. So it'll show you how we compare different distributions. So here's our data again. What's the chance you feel of getting rich by age 30? And we have it split by male and female. And again, we split it by males. So we say 98 out of 2459. We're only looking at the males. So what percentage of males feel there's almost no chance? What percentage of males feel there's some chance? What percentage of males feel there's a 50-50 chance? So on and so forth. If we added up these percentages, it'd be 100% because we're saying, okay, given you're a male, what's the chance from the different categories? And we can do the exact same thing for women. Given you're female, what's the chance you feel there's almost no chance, some chance, 50-50 chance, good chance, and almost certain? Now, what's interesting about these percentages is, okay, they're not the same, but for the most part, they're not off by that much. There's not a huge difference between the men and the women. And you might compare that. This is called a stacked bar plot. And it just stacks the different percentages here. You can't read this without a legend, so you know what's what. And you can visually see they're about the same. There's some differences. They're not exactly the same, but they're similar to each other. So you might say, yeah, feelings of men and women about the chance of being rich by age 30 is similar. Not exactly the same, but similar. There are more quantitative ways you can tell if they're the same or not, and we'll see that later on in the course. But right now, visually, you'd say slight change, slight difference, but not huge. Using R, well, we have the original table. Prop.table, comma 2 says, make these conditional things based on the column, so based on the genders. So given you're female, 4% feel almost no chance, 17% see some chance, so on and so forth. If we add up the females, that would add the 1. Given you're male, 3.9% almost no chance, 11.6% some chance, so on and so forth. If we add up the males, that would add up to 1. And then this funky looking candy cane graph is done by this. It's a bar plot on this proportion table. And then we add some junk in to make the colors and make the legend. This is called a legend and all stuff like that. So it makes it looking pretty. But again, for the most part, it's not that hard to create. Now, we analyze it again by just looking at these. Can we say there's a relationship between male and female? Does the distribution, does the percentages change? And we'll have to wait a little bit to actually say this technically, whether or not there's a difference. We just look at it visually. Yeah, the red's a bit different. Blue's a little different. You know, the aquamarine, I don't know what that is. You'd say there's slight differences. Not huge, but there's slight differences between men and women. So remember, though, even though there is a strong relationship, we can't get causation here. There might be another variable driving everything. So we have to be very careful and say it's not causation. There might be a relationship between different opinions between men and women, but we don't get causation yet. Another example, we ask kids, we ask teenagers from the UK and US, what's your favorite superpower? Mine is satire, of course. And here's superpower. Here's what country you're from. We asked 415 people total. And so 54 from the UK and said flying is their favorite superpower. 66 are from the US and said telepathy is their superpower. And this is overall. 99 out of 415 overall. So 23.9% said favorite was fly, freeze time. So the actual favorite overall was telepathy. 26.5% overall said their favorite superpower would be telepathy. Now we split it up by UK, and we can just say, we're looking at overall, that 48.2% of the respondents were from the UK, and 51.8% of the respondents were from the US. So a little bit more US respondents than UK respondents. And now, this is useful to look at and freeze and go through it and see what's going on. We can slice and dice this in different ways. We can say, given you're looking at fly, so 54 over 99%. So 54.5% of the people that preferred flying are UK. So this is the distribution of UK kids among the flying superpowers. So given you like flying, it's 54 of them are from the UK. given you're from, given you like flying, yeah, 54% are from the UK. Sorry about that, fat fingers doing this. Given you're from the UK, 54% of the 200 prefer flying. And we can say, given from the US, 23 of 215 is a distribution of super strength among the US kids. So again, you can say, are we focusing solely on the columns? Are we focusing solely on the rows of the data? God, it's late at night, so I'm just not talking correctly. And are we looking at in general? So are we looking at the table in general? Are we looking at just rows? Or are we looking at just columns? You can set this up in R if you're curious about how to do all this in R. Well, we're going to put the table in, so we can actually put the table in. We want to look nice. We put row names and column names in, and we can create this entire table in R. And then we can get the different conditionals. We condition on superpower, that's just looking at the rows. So this is if you add across, the rows add the 1. We can condition on the columns, and if you add down, the rows add the 1. So overall in the table, you can condition on the rows, so adding across, rows add the 1. You can condition on the columns, or adding down, the columns add the 1. And again, you can get the stacked bar plot, which says, let's compare distribution of superpowers in the UK and among the US. And there definitely is a difference. More kids in the UK like freeze time, and more kids in the US like telepathy. I have no explanation for that whatsoever. Hope you're having a great day. We'll see you in class.